I have one here actually. In short, Walter is a multi-radio system on module designed for IoT, and it is a single module that groups both local connectivity such as Wi-Fi and Bluetooth together with cellular connectivity, more specific narrowband IoT and LTE-M.
Hey, it's Eamon with ipXchange. We're in the ipXchange studios for another IP experience. This time I'm talking to Dan from DPTechnics. So before we get started and introduce you to Walter, Dan, what do you do at DPTechnics, and can you just tell us a little bit about the company?
Yeah, of course. Firstly, thank you for having me here. I am Dan. I'm the founder of DPTechnics, and I'm a technical person. I love to do stuff with electronics, embedded hardware design. So when I founded the company in 2017, I actually wanted to do something with that. And what better platform than IoT do you have to perform all these skill sets into products and services? So I started DPTechnics to be a development partner for our customers to design their IoT products from both a hardware perspective, embedded software, and also with Blue Cherry, a cloud software perspective. Because IoT is so complex, we felt that there was a need for especially smaller companies, but also larger SMEs to have a single partner that could group all skill sets that are involved in IoT. So that was how DPTechnics began.
Nice. So, what is Walter? And how did you come up with the idea? Because this does solve a big problem. So, tell us a little bit of about Walter and what it is pin compatible with.
Yeah, so I have one here actually. In short, Walter is a multi-radio system on module designed for IoT, and it is a single module that groups both local connectivity such as Wi-Fi and Bluetooth together with cellular connectivity, more specific narrowband IoT and LTE-M. And we see there are a lot of use cases for cellular IoT connectivity for long-range devices, sparse sensor networks, remote control of pumps, and so on and so on. But the use cases that I've just given are actually mostly focusing on low to medium volume products. And that's where it becomes hard to actually employ cellular IoT, because the module manufacturers and chipset manufacturers are actually focusing on the high volume market, such as smart metering, where you typically design devices to be in volumes of 100,000 pieces a year and more. And the reason for that is that as soon as you combine multiple radios in a single product, the certification becomes quite expensive. And you also, from an engineering standpoint, you need to take into account how the antennas are going to react with each other, how to get the software for all these things right. So it becomes quite an expensive development, and if you don't have enough volume to write off that expense, that development expense, then it becomes hard to deploy these kind of products. So within our customer base, in the last few years, we saw the need for cellular IoT in this low to medium volume product range. And that's where Walter comes in. Actually, we started off by using modules from PyCom, especially the PyCom GPy, which were fantastic modules, but actually now they are unavailable. So we were left with a gap where we had created some custom carrier boards for PyCom modules, but now these modules became unavailable, so we could not produce the products that we needed for our customers. And we did a market search for a good replacement, but we were not happy with what we found. So we set out to create a good alternative, but really important pin compatible and software compatible alternative with the PyCom GPy. And that's how our Walter adventure has started.
Cool. Just to clarify for our audience, which of the cellular technologies does Walter work with?
Mm-hmm. So, of course, as you say, cellular is a quite broad technology area. You have 4G that we all know from smartphones. Now 5G, everybody is talking about this 5G with extremely high bandwidth, low latency. But 5G is more than that. You also have low power wide area networking embedded. It started in 4G and it now evolved to 5G. And Walter uses two techniques. One is called narrowband IoT and the other one is called LTE-M. Both techniques actually were released in the 4G variant of cellular, but they continue to exist in the 5G variant of cellular. And this is really important because this gives confidence to you as a manufacturer or a designer that these techniques are here to stay for a long time. So Walter uses both techniques and supports both the 4G and the 5G variants of these techniques.
Cool. So you said that Walter is software compatible with the PyCom chip. In terms of programming, does that mean you could use the same IDEs? And we had a conversation before this call that Walter's not just about connectivity. So in terms of the other control capabilities of it, what does it offer?
Mm-hmm. So the original PyCom module, they were actually based on the ESP32, and they paired this together with the Sequans Monarch 2 chipset. Both are really capable devices, but of course, as we are now a few years later, we have implemented on Walter the successors of these devices. So we've upgraded the modem to the Sequans Monarch 2, and we've upgraded the ESP32 to the ESP32S3. And from a software standpoint of view, we've actually put the focus on being open source. Where PyCom was only supporting MicroPython, we actually support multiple variants of embedded IDEs or embedded frameworks. With that, I mean that we have created libraries for the ESP IDF and also Arduino, but we also contributed to MicroPython by creating a modern async.io based AT command library. And besides those, we also work together with Teutlang, which is a really cool containerized language for the ESP32. And very recently, we've contributed to Zephyr RTOS. We started a bit by contributing the driver for the Sequans Monarch cellular modem, and now we've also added board support for Walter. So as you see, there is software compatibility because we do support MicroPython, and people that come from the PyCom ecosystem will have a real easy time porting their existing MicroPython applications to Walter. Only they need to change some IO names. That's all. And people who are not familiar with MicroPython, they have enough choice from other systems to develop your software for Walter with.
Cool. So that's actually pretty incredible because you guys have basically created a solution to the, I guess, is it a shortage or a complete discontinuation of the PyCom chips?
It's the company has ceased to exist.
Oh, okay.
Before they ceased to exist, they actually made their GPy and also other modules based on ESP32 end of life, and they did a last time buy. So
Okay.
we saw that many customers still had a bit of stock left, but now it's completely disappeared from the market.
Cool. What kind of applications were those people working in as well?
Yeah, we see that for this kind of module where you have all this radio connectivity, there are actually two kind of major use cases. One is the gateway type of device where you use the Bluetooth Low Energy and the I/O to connect various sensors in the neighborhood and then upload this to with a cellular connection. You can use BLE sensors to create a local network or Bluetooth mesh, or you can use ESP now to do some local communication. And the other type of application is actually where Walter or PyCom modules are built into an existing application where they also run the application interface. So where the device, such as, for example, a remote pump control, road signage, and so on, where also the application runs on Walter.
Okay. So you can build a whole system around Walter. Nice.
Yeah, and that's one of the cool things about using the ESP32S3. With many people, of course, you know the versatility of this processor, but many engineers also think of the ESP32S3 as being quite power hungry, but that's actually quite fine. We have done a lot of work in optimizing the deep sleep power consumption. And of course, you can find microcontrollers which have a lower sleep current consumption, but what actually matters is the overall module consumption in deep sleep. And there we have optimized Walter to consume only 9.8 microamps in PSM deep sleep mode, so you can definitely use it for your battery powered sensors.
Cool.
But if you have an always on application such as a remote control where you do have a power connection, then the ESP32 is powerful enough, especially the S3 variant is powerful enough to create a local HMI, to drive some touchscreens, to do image recognition with a camera attached. You have the AI coprocessor inside. So it's powerful enough to run quite heavy applications, but at the same time, it's also more than capable of being used in battery-powered applications.
Nice. Going completely in a tangent, I noticed you mentioned ESP now. Can you tell us a bit more about that? Because that's a proprietary ESP protocol, right? And I've seen it pop up a few times, but I've never really had a proper explanation of it, let alone on ipXchange. So can you tell our audience a little bit about the benefits of ESP now, particularly considering it's within Walter's capabilities as well?
Mm-hmm. Well, we can make use of ESP now because we also have libraries that target directly the ISP IDF. And you actually can see this in use cases where you want extremely low latency and not a lot of overhead. And what it actually does is it uses the 2.4 gigahertz radio in the ESP32 or ESP32S3, and it does a point-to-point connection between ESP devices. And the key thing here is that you can have very low latencies. For example, when you want a high update rate vibration sensor between two modules connected, or even if you want to do image or voice transmission with ESP now, it's something between BLE and Wi-Fi. It has their specific use cases. And I think the low latency is the most important one.
Yeah. Am I right in thinking it's kind of that low latency, but also it's kind of aided because it has really small data packets as well? Is that right, or is it large? larger than
Yeah,
that?
well, I don't know by heart, but it can be really a very lean communication.
Yeah,
Like Wi-Fi and Bluetooth, these are really large stacks, and of
yeah,
course they come with standardization and versatility. So I would say if you can solve it using BLE and Wi-Fi, you're probably better off because it's standardized. But
yeah.
if you want something really small, and are focusing on extremely low latency, then ESP now could be worth looking at. But of
Cool.
course, it is something proprietary,
Yeah.
so I would say use with caution.
Yeah, yeah, that makes sense. Um, I guess probably a good thing to talk about would be Blue Cherry as well, because we've mentioned it very much in passing. But how does Walter work with your Blue Cherry platform, and what is Blue Cherry?
Yeah. Well, Blue Cherry is the IoT platform that we started developing in 2017, and it is a generic IoT platform with the focus on device management. So it contains over-the-air firmware update. It contains fleet management, so that you can manage which devices are deployed where. And there are two device types that we have in Blue Cherry. One is called the full device type, and that's actually for example, Linux-capable devices which run a full stack, including web interface. They have all business logic inside, and you want to access this web interface remotely without using a VPN or doing port forwarding, then you can just deploy a Blue Cherry connector on it, and you get your secure end-to-end encrypted connection to this web interface through the browser. You get access management, you get over-the-air firmware updates for Linux devices, and so on. And the second device type is actually what we call Blue Cherry Lite devices, and that's where Walter comes in.
Okay.
In that scenario, Blue Cherry is used to do protocol conversion, also over-the-air firmware updates. We can do both application firmware updates and modem firmware updates over Blue Cherry. And one of the really example use cases that I can give with Blue Cherry is when doing narrowband IoT, for example. This is the most slow cellular low power protocol. It cannot work together with TCP. In
Okay.
practice, you can get a TCP connection like MQTT or HTTP running on a narrowband IoT, but you will see connections dropping. You will see renegotiation. So it's not designed for it. You actually want to use a UDP-based protocol such as CoAP and DTLS to do your data transmission. But for many developers, this is quite new and complex to set up. So what Blue Cherry does, together with the open source libraries that we've created, is on the application side in your Arduino IDE or IDF or MicroPython, you just do MQTT as you know it, publish, subscribe. Our code then translates this into CoAP plus DTLS, and Blue Cherry at the cloud side translates this back to MQTT, and you can connect to a broker of your choice.
Okay.
Um,
Cool.
Not only is this a requirement when you do narrowband IoT, it's also a requirement when you want your data to be uploaded to, for example, Azure or AWS. These platforms only know MQTT or HTTP as an upload mechanism. And then your cellular device, which talks CoAP, it's not compatible. And Blue Cherry is all about getting data from point A to point B in the most efficient and secure way.
Cool. And in terms of the amount of devices you can put into that platform, what are kind of the limits?
Well, you can start with a single device just for developing, but we currently have devices from customers all over the world deployed in every continent. We have customers with only a few hundred devices in their
Okay.
fleets. We have customers which have thousands of devices in their fleet. The platform, today, we handle about 2 million messages every 24 hours.
Wow, okay, cool. Nice. So it's probably important to tell our audience that Walter has been made possible through crowdfunding, and you're working on the first 1,000 units at the moment. Assuming all goes well and is received with praise, which it does sound like a really good module, it's just a shame that I didn't get to see it. So for those of you who've been watching the Hardware Pioneers Max content, there was a Walter in the show, but it was being taken around by someone, and we didn't manage to get an interview on it. So it's good that I managed to follow up with Dan now. But what quantities of these are you expecting to produce when you do a full commercial release?
Mm-hmm. With the help of crowd supply, we've launched the module, and as you said, we are now creating the first 1,000 modules, and we are really proud that we are producing here in Belgium. It's a European made product, and we see that the use cases for Walter, when we are now doing our first commercial contacts, it's for things with starting from 100 devices a year up to 10,000 devices a year. So we're definitely going to scale up production, in our opinion, as we see it now, between 10 and 30,000 Walters a year.
Cool, that'll be sweet. So if an engineer, I guess, first scenario, an engineer used to use the PyCom chip, they approach you, how many Walters would they need to be ordering for it to be viable, for it to be a viable project for you? And then for someone who's completely new to it, what is the best way to get started with Walter?
Well, actually, I would say start off with buying a development kit. The development kit, you can buy just a single quantity of it. It contains Walter, it contains the pre-certified antennas, the USB-C cables to connect directly to your development machine, a Soracom SIM card, and really important, it contains some support from our team directly. So that means that you can get started right away. It comes pre-flashed with a tracker application. So when you receive Walter, just plug it in, do a walk in your garden and see how the GPS works, how the cellular works, and you see data coming up onto our demonstration platform right away. And then for when switching over to commercial implementation, we have a commercial MOQ of 50 pieces, so that supports really low volume products.
Cool. And just to double check, is the GNSS is the positioning on Walter itself, or is that just on the board?
It's on Walter. It's on Walter cell. Yeah. So the cellular modem that we use, it's this one from Sequans, which is a French module maker, but they also make the chipset. So that's really important that it's a European chipset, and it actually shares the radio with the cellular. So that means that you should not expect the GPS or GNSS in Walter to be a really high frequency, just as in your car where you get an update every second. But because you can also not use it concurrently with the LTE connection. The idea behind the GNSS is for low update tracking. Like tracking your bike or a pet tracker, where you use the sleep time of the LTE connection to receive satellite information. And because it's doing this low frequency updates, it focuses on being really low power. And we've done two things to get the GNSS low power. First thing is that we've selected amplifier components that are really low power, and also we don't support an active antenna, but also only a passive antenna.
Nice.
That means
Okay.
that you can get a really flat stick-on antenna, so a really small solution size. And also we have completely predictable power consumption because we know what the antenna is going to use, or the amplifier
Yeah.
what it's going to use to amplify the signal.
Cool. So in terms of kind of closing thoughts, if you could summarize the benefits of Walter with 3 sentences, what would you say?
Let me let me think to get a good sentence. But I would say if you want to design a product that needs cellular connectivity and local connectivity, you want to get your time to market as short to possible and don't need to worry about certifications, and at the same time have complete freedom on the software and SIM card connectivity, then Walter is an ideal product for you if you are in the volumes between 50 and a few thousand devices a year.
Nice. Cool. I think that's been a really, really nice introduction, one, to Walter, but especially to DPTechnics as well. So, as always, I'll do a technical write-up of Walter so you can see the specifications and apply to evaluate it on the ipXchange website. But thank you so much, Daan, for being here for this chat. And yeah, really exciting product. We'll have to do a follow-up when you go into mass production and see what other things your customers will be doing with Walter.
I'll make sure that a Walter arrives in your office as soon as the production run is complete so that you can have a go with it.
Hey, yo, where my engineers at?